ultimate route to JEE success with JEE Test Prep app by Extramarks, adaptive testing platform, India's top faculty, micro-scheduling, live and recorded sessions, doubt-solving sessions, national level weekly tests, analytics and reports. Download the app now.
Hello students, today we are going to discuss about a very important topic, fluid mechanics. In that there are two parts, one is statics part and the other is dynamics part. Where statics parts we are going to discuss about the fluids which are at rest, and the dynamics part which includes all the types of flows and all, streamline flow, viscous flow, everything. So let us start the session now. So topic is mechanical properties of fluids. First we have to talk about the properties of the fluids and pressure. So first, beforehand, what do you mean by fluid? Generally, first you should know about what do you mean by fluid. Fluid means which will flow. Generally, so many of the students has a wrong idea that fluid means it's only liquid. No, gas can also be included in types of fluids, because the substance which can flow, solid will not flow. Solid can roll, solid can move, but it will not flow. So solid won't be included in the fluid type. But whereas gas and liquid like water, okay, so these things will flow from one place to other place. So such type of substances are called as fluids. Okay, first one, types of fluids, and next topic we are going to discuss about pressure and types of pressures and properties of fluids. One by one we will see. The first, fluids. So you can see it is very clear, fluids are the substances which begin to flow when an external force is applied to them. So there are two types, as I said, one is liquids and other is gases. Now one more, shear stress. You have been learned in elasticity lesson. Shear stress of fluids is million times smaller than for solids. Okay, coming to the properties of fluids, there are like study of mechanical properties. Before that, as I said, that fluid statics and fluid dynamics. People may call it as hydro as well. So now coming to the pressure topic. Pressure, else an object submerged inside a fluid at rest experiences a normal force. Obviously, normal force we already discussed, like normal reaction, exerted by the fluid on its surface. That you will feel when you dip any plastic bucket or something like that into the water. Parallel component of force result in the flow of the fluid, and whereas pressure of the fluid is the normal force, we try to understand, pressure always acts normal to the surface, exerted by the fluid at rest on unit area of cross section. So mathematically I can say this as F perpendicular by area. Understood? Area of the given contact surface. And dimension formula you had been read in first year as well. And SI unit of pressure is Pascal. And pressure is finally, this is scalar quantity. Now how to measure the pressure? It is so very clear. You see this experiment. If there is an external force applied on this piston where the spring is connected, so obviously this spring will be under compression. So here it was written, spring gets compressed. So if I release this external force, now spring is compressed like this. When I release, then spring will push the piston up. So that force is also called as restoring force, which helps the piston to come out. That is restoring force, which is also called as spring force. Okay. So what does it mean? The spring force, you know, you studied F is equal to kx in magnitude, but strictly talking, F is equal to minus kx. You know, that is opposite to displacement. So displacement, when I am pressing the piston down, displacement is down. So restoring force will be up, because minus sign says that in physics, opposite direction right now in this case. Now, next topic is about density. Generally, you studied about density, rho, or people may say D. D is nothing but mass by volume. Wherever generally density is there, that should be divided by volume in general cases. But there are so many types like areal density, linear density, that we will talk later on. Of course, you had been done this in Centromas lesson. Okay, let it be right now density. Because liquid has no particular shape, it will occupy the shape of the container. Container will be obviously three-dimensional. So we have to consider the volume. So density of the substance is defined as the mass per unit volume. That is rho is equal to m by v. That is what here it was written. SI unit of density is kg per meter cube. Dimensions of density is m L per minus 3. A density is a scalar quantity like pressure, as I discussed. Pressure is a scalar quantity at last point, and here also density is a scalar quantity. But very important point for water. Density of water at 4 degrees Celsius is absolutely, it is maximum. Please try to recollect this when I ask the question after 2 or 3 lectures. So density of the water is maximum at 4 degrees Celsius. Okay. Then what do you mean by relative density? You know, in first year kinematics chapter, there is a relative velocity. Relative means with respect to each other. So there the comparison is VA minus VB, but here the comparison is density of substance divided by density of water. Water at 4 degrees. There subtraction relatively means, here division relatively means. Please try to understand. Then relative density is defined as I said, maybe relative density of solid or maybe relative density of liquid. So liquid may be kerosene, petrol with respect to water. Okay, and this was very important question for competitive level. It was unitless as well as dimensionless, because density by density they will get cancelled. Now one of the solved example we will see. A mixer is there of n number of masses, m1, m2, m3, mn, like number of liquids are there. Relative density, other name is specific gravity. No need to worry about that. S1, S2, S3 and so on, Sn. Find the specific gravity of the mixer, means relative density of the mixer. The water maybe generally we have to start from the ground level, that is basic level. So density of the mixer will be total mass by total volume. Total mass is m1 plus m2 plus m3 and so on. Total volume is v1 plus v2 plus, you can see here it was given like this. Total volume is like this, but volume can be written as mass by density obviously. So we can write like this, right? So then after putting here, substituting v1 plus v2 plus v3, m1 by s1 plus m2 by s2 plus m3 by s3 like that. Then finally into rho w, how it came, you can see here. Let me explain. Density of the first particle is rho 1, m1 by v1. Second is obviously water, rho 1 by rho w. That is nothing but specific gravity. Density of the solid or density of the body by density of water. Then S1 can be written as rho 1. In place of rho 1, I am placing what? M1 by V1 into rho W. So V1 is finally M1 by S1 rho W. So substituting this in the expression, we will get finally this one. So please concentrate. Don't try to by heart the formulas at last, whatever you are getting. Try to understand the concept. First step is the last step. Now we are going to calculate pressure. You see, if I take a cylindrical vessel which contains liquid, and then in that one a small shaped cylinder I am considering once again, which is having a mass small m, so weight will act downward, and you can see pressure is nothing but the normal force. You see F2, nothing but F2, F1 here. So one more line, pressure is always compressible in nature. That is very important. So all the sides pressure will try to compress. How? Normally. So now pressure on the top will be by giving the formula F1 by A1. So F1 will be P1 into A1, means A only. Similarly F2 will be P2 into A. And weight is acting downward. As you know that. So net upward force is F2 minus F1. Net downward force is mg. So both should balance. So obviously P2 minus P1 into A is equal to mg. So mass of the fluid m is equal to rho v is equal to rho You can see here volume can be written as area into height. Yes, obviously area into height. Then P2 minus P1 is rho GH. This is most important whenever you are considering a pressure difference between two different points which are not on the same horizontal line. You can see 1, 2, not on the same line. There exists a gap between the levels. So obviously at that time pressure difference is defined as rho into G into H. So obviously I can say pressure difference depends on density of the liquid. Pressure difference depends on acceleration due to gravity, and it depends on the height of the liquid column H. So if at all it is open to atmosphere, that will be obviously P atmosphere. So that is what P2 minus P1, you know, where depth is more, there pressure is more obviously. Then you can see here, as from the previous one, P2 minus P1 is equal to rho GH. What is P1 here? P atmosphere. Then this P atmosphere goes that side. Then P2 is equal to P atmosphere plus rho GH. That's it. Now, we are talking about a very important topic, which is hydrostatic pressure. Hydrostatic pressure in the sense, when the fluid is at rest, the pressure exerted at the bottom, you can say, on the horizontal line, you can say that is hydrostatic pressure. As we discussed, let me see here, A, B, C, D are different shapes, and I am considering that P at the bottom. Each container bottom pressure is PA into rho GH. If suppose heights are different, this is H1, this is H2, what will happen? If wherever pressure is more, liquid flows from high pressure to low pressure, obviously. So then, but liquid you see in this container, containing different vessel shapes, it is at rest. So obviously, no more question. H1 must be equal to H2. Otherwise, you see on a horizontal line, if it is H1, this is H2, H1 greater than H2, liquid should flow from high pressure to low pressure. But you can see in this diagram, liquid is at rest. What does it mean? No pressure difference. What does it mean? Heights must be same. That is called as hydrostatic pressure. Now you can see here. So these are also different shapes. It doesn't mean they have different pressures and all, but you have to see here, height of the liquid columns are same only. Force exerted is F normal to this bottom area everywhere in each and every diagram. But F is equal to W here, F is less than W here, and F greater than W. So what is W? W is weight of the liquid. Even though the shapes of containers are different, pressure in all three cases are same. Why? Because area is same. So obviously pressure depends on rho GH, heights are same. So whatever may be the area or whatever may be the force, pressure directly proportional to rho GH. So same liquid, so density is same at the given place, same G. So obviously G is also same, and all the containers are having same height. So that is the reason why rho GH is same for every bottom. So now atmospheric pressure. So this is the standard value pressure. Atmospheric pressure is at the sea level at normal temperature and pressure 1.013 into 10 power 5 Pascal, which is also termed as 1 atmosphere. How to measure this pressure? The one is by using Mercury Barometer, atmospheric pressure. One is by using open tube manometer to find pressure difference. People may call gauge pressure. Now coming to Mercury Barometer, you see actually this is of 1000 mm. 1000 mm. So when initially I took this test tube with a fully filled mercury and I inverted into the container, so obviously this space you can see, some of the liquid will come out, liquid in the sense mercury, and it will stop surprising. It was stopping at exactly 760 mm. So what does it mean? When it was stopped at 760 mm, that means at this bottom pressure is rho GH, that should be equal to the atmospheric pressure. So it is so very clear, this pressure, both are balanced. That is why it is height is taken as 76 centimeters. So units of pressure is centimeter or mm of mercury, or torr or bar. 1 torr is equal to 133 Pascal, or 1 bar is equal to, this is 10 power 5 Pascal. Okay, 10 power 5. Next, open tube manometer. The shape first, let us see the shape first. Open tube manometer means one side it is open, the other side it was closed, like this. Mercury is there here. Here also mercury is there. So pressure at A is equal to pressure at, that is nothing but atmospheric pressure only. You can see here. So when the liquid is at rest, so if I say, if I drop a horizontal line, I said on the horizontal line, if I take 2 points here and here, you can see if the liquid is at rest on the horizontal line, pressure at this point must be same. So this is point A, let me say this is point B, let me say. But extra pressure, you can see here, pressure at point A, I can say rho GH, okay, rho GH plus atmospheric pressure. So pressure at point A is equal to pressure at point B is equal to atmospheric pressure plus rho GH, because atmospheric pressure is also acting, because that is open tube, one side is open. So now the pressure difference P minus PA is called as gauge pressure, or some people may call gauge pressure, it doesn't matter. So that is equal to rho GH. So this is what about all properties and pressure we discussed, density we discussed, relative density we discussed, and what types of pressures we discussed, how to measure the atmospheric pressure we discussed. So I hope you will practice. So till then, happy practice. Thank you.
For more such videos, please like, share and subscribe to Extramarks Test Prep YouTube channel.